Hello, and welcome back to the GT chapter. So this is video number 4, Mapping the Earth. And when we start with mapping, right, we want to display things on a map, but we also want to be able to reference where exactly they are. So the very first component of mapping is the idea of the geographic grid. So if you've ever taken a geometry class, right, you've had X and Y axes, right, horizontal and vertical, or even if you haven't taken geography, if you ever played a game like Battleship, right, B6, you go to cross B6 and where they intersect, right, that's a specific point. And that's the same system that we use to map the Earth. But instead of having B and 6, we have lines of latitude and lines of longitude. And these form the vertical and horizontal axes in a grid, a checkmark of squares. Okay, so let's get more into that. Let's talk about latitude. Latitude is how we measure distance north and south. You are so far north of the equator or so far south of the equator. And it's a measurement of angles. So 20 degrees, or you might have heard that we are approximately 45 degrees north, or the 38th parallel. These are all terms of measurements of latitude. And it's an angular measurement. So it's a line that goes around the world. Any place on the surface of the Earth, if you have any 2 points, and they are both the same distance north, say 23 degrees north, they are said to be on the same parallel line. So a parallel is a line that connects 2 points. I'm going to show you what this looks like in just a little bit. But the most common and the most famous parallel is the equator. And the equator is a line of left that goes right around the middle of the Earth. So if you see right here, here's the Earth, right? The North and South Pole. And the equator goes around the middle of the Earth. This is a line of latitude, or a parallel. Every point on the equator is the same distance north or south, 0 degrees. Divides the Earth into half, two half spheres, or hemispheres, the northern hemisphere and the southern hemisphere. So we measure, let's just talk about north, since we're right here in the northern hemisphere. How do we actually measure north and south of the equator? It's a measurement of angles. That's why in geometry class you measured angles. If you find any point, so if you're standing on this point on the surface of the Earth, and you drew an imaginary line from your feet straight down to the center of the Earth, and then back out to the equator, that forms an angle. And the measurement of that angle, in this case 45 degrees, you are said to be at 45 degrees north. So this point is at 45 degrees north. It can be anything between 0 and 90, because if you're at the North Pole and you drew a line, it would go straight down to the center and then at a right angle or 90 degrees out. Conversely, you can do the same thing south. You can measure here, you can do 45 degrees south, 90 degrees. You can only have a measurement of 0 to 90 north or 0 to 90 south. Because what happens, if you go over here, the angle flips. So you go from 0 to 90, and then from 90 back down to 0. 0 to 90, and 90 back up to 0. Here's another view. Say you're standing here in the middle of the ocean. That's pretty cool, right? You draw that imaginary line down to the center of the Earth and back out, and you measure the angle. In this case, it's 40 degrees. Right? So all these lines indicate that this is 10 degrees north. So this is the 10 degrees north. This is the parallel. Every point on that line is at 10 degrees north. You put the chunk back in, so it kind of looks like this. This is the 40th degree north parallel. So that's the first part of the grid. And by the way, you might have used these terms. You've heard these. We talk about latitudes at the tropical latitude. Certain lines of latitude have names. This is the Tropic of Cancer. It's 23.5 degrees north. We're going to talk about this in the next couple chapters, why this is specific. But anything between 23.5 degrees north, the northern tropic, and the southern tropic of Capricorn is considered the tropical latitudes. And when you think of the tropics, what first comes to your mind? What image? Maybe palm trees, beautiful, warm, sunny beach. Generally speaking, you can see the colors here, right? The sea temperature, the surface of the sea, the temperature is the highest generally in the tropics near the equator. And as you move north towards the poles or south towards the poles, it gets colder. So we'd be in what they call the mid-latitudes. By the way, a little hint if it helps you remember this, lines of latitude are like rungs on a ladder. Latitude and ladder, right? Like you're grabbing up with your hands or your feet. So that's the horizontal axis. The next one is the vertical axis, and this is longitude. And longitude is a measurement of east or west, starting at the prime meridian. So a longitude is a line that starts at the north at a pole, north or south, goes all the way around, back up the other side of the planet, completely encircles the planet, and it goes from North Pole to South Pole and back up. And that is a line of longitude. And just like with latitude, you had parallel, we often call lines of longitude meridians. So you look at a map of the Earth right here. You start at the North Pole, and you go all the way around and come back up the other side, and that is a meridian, or a line of longitude. Okay? Now here, again, you're measuring east and west. East and west, not north and south. So how do you determine what is east and west? Well, you pick one of these lines of longitude, you pick a meridian, and you make it the starting point, 0. Now, any one of these could be the starting point. The prime meridian that we use today, 0 degrees, goes through Greenwich, England. You might have heard the term Greenwich Mean Time. That's because all different countries had different prime meridians. Every country put the prime meridian through their capital. So in France, the prime meridian went through Paris, or in Turkey, it went through Istanbul. But in the 1700s, the British Empire was the biggest empire. In the 1800s, they made most of the maps of the world, and it just kind of stuck. So there's really no logical reason for it, other than this is what everyone had agreed to do, or kind of was forced to do. But the way you measure is here is that 0 prime degree, right here, this prime meridian here, same thing here. And here you're looking down at the top of the world, and you're over here in Canada, you just measure that angle right there. So this angle is 60 degrees. This angle is 90 degrees. So you're just measuring the degrees, again, just like north and south. So we start at 0, and we go 30, 60, all the way up to 180 degrees. So if you've taken a math class, you know that there are 360 degrees in a circle, and half of 360 is 180. You are halfway around the world. Now, we have west. They go up to 180, just like the poles go to 90, they go back down. So we go from 0 up to 180, and then from 180 back to 0. And the prime meridian also divides the world into half, an eastern half and a western half. And you'll hear that term hemisphere. So, now that we know that, right, another thing to know is that we don't use miles west or north, we use latitude and longitude, use degrees. So you measured in math class, you have a degree, right? This is 0, a right angle is 90. But what if you want to measure between the degree? So you are at 45.5 degrees. Traditionally, you would say you were at 45 degrees north and 30 minutes, because there are 60 minutes in a degree. It's like there are 12 inches in a foot, or 100 centimeters in a meter. That's how that divides up. And then, here's a shocker. I want you to think about how many seconds do you think are in a minute? And if you didn't say 60, then we need to discuss your concept of time, because this is basically how a clock is organized. This would be 12 hours. This would be 1 hour, 1 minute, and seconds. 60 seconds. I can't talk. 60 seconds in a minute, 60 minutes in a degree. So you could be really specific and say that I am at 45 degrees, 90, or 45 degrees, 54 minutes, and 33 seconds north. And it's just like saying that instead of saying you are 5 feet tall, you are 5 feet, 2.5 inches tall. So it just gives you more precision. Most computers don't do well with degrees, minutes, and seconds because they want everything to be decimalized. So there is a measurement of decimal degrees. So you might see this on a map that you are 45.6789766 north. And it's just another form of measuring. Also, because computers need things to be more mathematical, we usually give positive and negative numbers. So 45 degrees north in a computer is a positive number, but 45 degrees south would be a negative. So you'd see negative 45 degrees. Same thing with east and west. Okay? So if you were going west, 80 degrees west would be negative 80 degrees west. So on a map, it would look like this. Here's the prime meridian, which is 0 east and west. Here's the equator, 0 north and south, and we start at this point. Little interesting trivia fact. There is nothing here. It's the middle of the ocean off the coast of Africa. So geographers jokingly say this is called Null Island, N-U-L-L, as in there's nothing there. It is the 0-0 measurement. If you ever do any kind of geographical work and you make an error, you get a result of 0-0 by mistake. You're subject onto Null Island. I found it fascinating. That's just me. But starting north, you can see we go 10, 20, 30, 40, 50, so on. Then going south, negative 10, negative 20, negative 30. And same thing, east, 10, 20, 30, and west. So I'm not going to make you do this. This is an exercise if you want to do it on your own. You can come back to this image. Using the knowledge I gave you, you should be able to determine what these points are. So let's just take, for instance, the first one, the Dead Sea in Israel. It's at 31 degrees north and 35 degrees east. So you would find what you think is the 31st line north, and it might not be exact, so you're going to kind of have to figure that, what, this is 0, this is 90, and we have 1, 2, 3, 4, 5, roughly 5 or 6 lines. If you want to start from 0, so it would be 1, 2, 3, 4, 5, whoop, and 6. Again, that would be 1, 2, 3, 4, 5, 6, and the 90 would be what, 1, 30. So these are roughly 15 degrees. This is 15, 30, 45, 60, 75, and 90. So this we know would be what? I just said this would be 30 degrees north. Well, look, there's 31, so you know it's probably A, D, or F, right? So we now know that. The next thing is 35 degrees east. So here is 0, and if you think of a map, this way is east. Now, this goes from 0 to 180. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 into 180, my math is rusty. Let's just say 12 into 18 is 1. So they're about roughly 15 degrees again. So this would be 15 degrees east, 30 degrees east. So let's look at D again. We know that it's 30 degrees north and 30 degrees east. And that's pretty close. So you could say this is the Dead Sea. We also know, since this is 30 degrees north, the Dead Sea is at 31. The Himalayas are at 30 degrees north. And Mount Whitney in California are at 36 or 30, roughly 30 degrees north, right? So let's just look at F. We know F is roughly 30 degrees north. And now we know this is what? This is 30. Add 15 would be 45, 60, 75. And this is halfway, so we'll say like roughly 80. So 80 east, right? So 30, 79. So you can know that. So you could go through all these and practice that. It's actually, once you get the hang of it, not that hard. It's just like Battleship, but on a global scale. But that kind of leads to this idea of cartography, which is where I'm going to pause this so you can all get up and take a break. I'm going to make a cup of tea, and we're going to come back and talk about the art and science that is met.